Hi everyone, welcome back to my channel. In this video, we are to extend the domain theta to all real x. So let's first look at the angle theta we have in terms of the right angle triangle. And we are to take one of the acute angles to denote that as theta. And we use this angle and take two sides of the right angle triangle to get the ratio. So if you are to look at the angle theta, since we are taking an acute angle, it's been restricted into 0 to 90 degrees, excluding 0 and 90. And we are to extend that using the concept unit circle. Let's look at the unit circle. I believe you know the two features of unit circle. The first is center is at the origin, 0, 0, and it has the radius of 1. And let's look at this yellow arrow. And this is what we call the positive x direction. We are to take theta using this positive arrow. If we are to start from this positive x direction and go anti-clockwise, this angle we say is a positive angle. And if you are to take the same theta, but you are to go anti-clockwise, then we say this angle theta is negative. So remember, the direction when we extend the angle theta to unit circle is very important. By using the unit circle, we have extended theta to all real x. Suppose I am to take a line from the origin, the center, to one of the general points on the circumference, and I would like to label this point as x, y in general, and I'm going to create the theta. You are to start from the positive x direction and to the line you have. This is theta. And now I would like to express x and y, the movement along the x and y axis with respect to theta. We are to create a right angle triangle. This is your horizontal movement. And if you refer to the red dashed line here, its length should be x. And we get the vertical direction. And the length of this blue dashed line should be y, because the movement along the y-axis direction. And let's refer to the hypotenuse we have in our right angle triangle is the distance between the center to the circumference, that is the radius. Radius in unit circle should be 1. And let's rewrite x in terms of trigonometric function. So we are having x, 1, and theta. Before that, we are to name the three sides we have. So the hypotenuse will always remain as the hypotenuse. Opposes the angle theta. Y is our opposite side, while x is our adjacent side. So we will use x, the adjacent side, and 1, the hypotenuse. So which trigonometric function should we use? So I believe it's car involving adjacent and hypotenuse. I believe we should use car. Cos theta is equal to adjacent over hypotenuse. And we are to substitute the corresponding adjacent and hypotenuse to this function. I believe your adjacent is the x, and hypotenuse is 1. If you are to rearrange, I believe you should get your cos theta is equal to x. X divided by 1 will give you x. So in place of x, you can write cos theta. We are expressing x, the movement along the x-axis, in terms of theta. So cos theta. And now I would like to express y in terms of theta as well. So y is the opposite side, and we are to use the hypotenuse. I believe we should use SOR. Sine theta. Sine theta should equal to opposite over hypotenuse. And in place of opposite, you are to put y. And in place of hypotenuse, you are to put 1. And I believe your sine theta should equal to y. So in place of y, you can put sine theta. Before we move on to tan theta, let's look at the cos theta and sine theta we have. You now have two methods to represent a point on the Cartesian plane, that is in terms of x and y, that is the movement along the x or y axis, and you can also express a point in terms of theta. So in place of x, you are to say cos theta, and in place of y, you are to say sine theta. So you just need to remember the two equations we have. When we are referring to cos theta, we are referring to the x value of a coordinate. And when we are referring to sine theta, we are referring to the y value of a coordinate. Moving on, let's talk about tan theta. So tan theta should equal to opposite over adjacent. And if you are to refer to the opposite, I believe is y. And if you're referring to adjacent, I believe is x. And now we are to look at the last equation we have. If you are to see y, we can express y in terms of theta. So sine theta. And over x, you can express x as cos theta. So cos theta. Tan theta is equal to sine theta over cos theta. The last thing I would like to talk about is the extension of theta. As we said, we used to have theta in between 0 and 90 degrees, excluding 0 and 90 degrees. And now your theta is an element of real numbers, so you can take any theta you would like, but we usually restrict our theta in between 0 degrees, including 0 degrees, and 360 degrees, including 360 degrees, to get a meaningful answer. So for example, we are taking a theta, and if I am to find its sine theta, I believe that's asking for y value. You can drop a horizontal line, and that should give you the y value. So this is your y1. But remember, we are extending the angle theta. If I am to reflect this line across the y-axis, let me denote it as phi, and the angle theta, since I reflect it, is this one. And you should see that if I am to find the y value of the angle phi, so sine phi, I should get the same y value. You should see a problem when we extend theta to 0 degrees. So you should see the problem here is that when we extend the angle theta in between 0 to 360 degrees, when you're finding the trigonometric ratios, sine theta, cos theta, and tan theta, they usually give you more than one answer. So normally two answers. So when you are finding the trigonometric ratios, when your theta has been extended in between 0 to 360 degrees, you should provide two answers to the question.